If, for example, you want to get a list of squares of integers in a given range, you'll create an empty list, write a loop in the range, and append the squares to the list, which is of course straightforward, and that's what everyone does. Instead of writing this 3-line code, you can make it even more concise using list comprehensions in Python. It provides you a simple way to create lists with an iterable or an existing list in a single line. Let's look at the syntax. List comprehensions create lists using an iterable. The output elements are in the form of this expression, followed by a standard for loop surrounded by square brackets. Let's look at the same example using list comprehensions. Squares equals square brackets, and we use square brackets because lists use square brackets. Then the expression I square, which is the output element. Here I is the element of the iterable which we iterate over using the for loop, just like we would write a normal for loop. To create an iterable, we can use range as before, starting from 1 to 10. Let's run this, and there you have it, the simplest form of list comprehensions. But yes, instead of using range, I can just use an existing list as I said before to generate a new list, like this for example, and it works as expected. That was surprisingly easy. Now what if I want squares of even numbers only? In the traditional method, you will add an if block in the middle to check if it's divisible by 2. But in list comprehensions, you can just add the same if conditions right here using this syntax. Let's type that out, and there's your list of even squares. Okay, that's great, but one loop is too easy. Now what about nested loops? Assume I have an order 3 square matrix and I want the principal diagonal elements. So traditionally I will write 2 loops, the outer one for rows and the inner one for columns. And the condition being, if the row index and the column index is equal, then I'll append them to the principal diagonals list. There it is. This can be done in list comprehensions using this syntax. Hence 2 expressions and 2 for loops here, and we will add a condition to this like before. Back to code. The expression will be to use the row and column index to access the element in the 2D list. I is the row index for the outer loop in range 3, and j is the column index for the inner loop in range 3. Then we will add an if condition where both indices should be equal. There is the principal diagonal elements of the given matrix. And of course we can add more expressions for deeper nested loops. Till now we have seen list comprehensions with single or multiple expressions. Now what if the expression itself was a list comprehension? This is called nested list comprehensions. In this syntax, as you can see, the expression for the outer list comprehension itself is a list comprehension. This can be particularly useful for creating matrices. Let's create a matrix of order 3 filled with random integers. First let's import random. We can just do values equals square brackets, then an empty list comprehension which we'll come back to for I in range 3, back to the expression. Here we can just do random.randent from 1 to 10 for j in range 3. So this should generate you a 3 by 3 matrix, and there it is. That is it for list comprehensions.